welcome back. Now let us discuss about two main operations that are performed on processes by the process management system, and they are creation of the process and termination of the process. A process usually is created by calling a system call fork. So let's just try to look at what would happen when we turn on our system. So when we turn on our system, the first process begins to work, and that is what we call the booting operation, and BIOS, which was stored permanently on the motherboard, will start running, and that starts booting the kernel. So the first part of the kernel that gets booted is a scheduling component, and let's say its PID is 0. Then we create another process called init that's going to initialize the resources. So what all resources are connected to the system, it just verifies that, and the appropriate drivers are loaded, and these drivers are then activated. Because an operating system works for a common system which can have almost infinite components in it, can be connected with infinite components. So instead of working with everything and loading whole thing onto the memory, what is done is just look at what the peripherals, what resources are connected to the system that are required for current running. Like keyboard is connected, mouse is connected, screen is there, and all that. So to make sure that these work properly, proper drivers are required, and looking at what keyboard is connected, appropriate driver is loaded onto the main memory. What the mouse is connected, appropriate driver is loaded onto the main memory under the kernel, and so on. So that's all happens during the init. And another requirement is to make the memory work as per our requirement. So we need to initiate the memory management component of that. So there is another process which is created through fork, and that is called page out, and this is taking care of the memory, its pages, and then updating the data on the pages with the disk and all that. So that is taken care by another process. Then say fs flush is the one which is responsible for the kernel operations related with file operations and all that. So that way we begin with the initial part of the one process, that is the scheduler, and then it creates another process in it. The scheduler creates one more process, page out. The scheduler creates one more process, fs flush, that's required for beginning the actions, and then init will initialize the internet component of that, and then initialize the display component of that, and this continues. So that's where the process creation is required, and that's how it is done. That is done through fork system call. So let's look in detail what fork does. Fork is a system call that is called in one program, and the program in which it is called the parent process. The process in which the fork instruction is executed is called the parent process, and once the fork instruction is executed, the whole copy of that is created on the memory separately, and then the two processes start executing. One process is the parent process, and another process is the child process. And usually what happens is, when a new process is created, the child process, then the child process starts executing, and once the execution of the child process is done, then it exits, and the parent process is waiting till the child process exits, and once the child process exits, the parent process continues its other activities. So this is how it looks like. So just we look at one simple code. So here we have a PID variable that is going to store the process ID of the process, and now we are using a system called fork to create a child process, and this child process, once created, will return an ID, and that is stored in the variable PID. So there are three possibilities. Possibility that child process may not be created, so something goes wrong, then it fails to create a child process. In that case, we get a negative number as a PID, so it returns a negative number for failure, and if the number is negative, then we get PID less than 0, then we just say that something went wrong, we display that error message and return a 1, and then it returns a 0 to the child process, returns 0 to the child process, and returns the ID of the new process created back to the parent process. So now through this, because the same thing is made two copies and both are running separately, now we want to make sure that one should work like a parent, other should work like a child, and here the PID value comes to our rescue. The same code is run two times separately, just a copy of that is run separately. One is called parent process, other is called child process, and same code has to be used, and they should do different actions. So to make sure that different actions are done, then PID comes to our aid. So the child process receives the PID as a 0, and if the PID is 0, that means you are looking in the child process, then do something. So it is going to just go to this particular address and execute ls instruction, that is printing the directory onto the screen. Else, so one we have seen PID less than 0, that is getting a negative return value, that is when something goes wrong. If it is 0, that means it is a child process, and if it is neither negative nor 0, that means it is something greater than 0, which means that it is the PID of the child process which the parent gets back. Now it's not necessary for the child to know the process ID of the parent, but the parent has to know the process ID of the child it has created, because it has to wait till that child completes its action. So it should keep tracking whether that given child is stopped working or not. So for that, parent should know the ID of the child. The child need not know the ID of the parent who created it. This doesn't matter, but parent should know what all children it has created, and the parent should be alive till all the children are working. So once all child processes exit, only then the parent process should exit, otherwise it has to wait. So that's what we are talking of, but yes, I know it's a little confusing, so let's see the same thing in detail now. Yeah, we are here this instruction we had just executed. So earlier this was only one copy, and after executing this instruction, this line fork means this whole code we have another copy. This becomes parent process and this is the child process. So in this process this component will be run because it is getting a PID of the child. The PID of the child returned is 123. Therefore it is neither negative nor 0. Therefore this else will get into that. This PID less than 0, it goes in. If PID is equal to 0, it goes here, but none of them is true because what we have is PID of this child process, which is 1, 2, 3, and therefore it gets into the third component, which is the parent process. And here parent process is just waiting for the child to complete its task. The other side, what is happening? We get a PID equal to 0 because this is the child process created, and in this case where we have two sets of codes, two sets of variables. Here we have one variable PID, here also we have one variable PID. The value of PID in this set is 1, 2, 3. The value of PID in this case is 0 because it is the child process created by this instruction. Therefore after this line the PID here is 0. Therefore it is not negative, so it moves here. It is 0, therefore it enters into this one and executes this one. And after executing this, once it is done, its work is over, and once its work is over it returns 0, and when it returns a 0, then the process, which is a parent process which was waiting for the child to complete, it gets a 0 back, and when it gets a 0 back, then this part is also over. This word wait also is over. Wait means it is in the infinite loop till we get a 0 return from the child process. Once we get a 0 from the child, this part is over, and then it will return 0 to its parent. So whoever has created this will get a 0 back, and that if it was waiting for this to do, then it will continue its action. So that's example I hope will clarify what fork statement is and all that. Now coming to termination. So when the process completes its execution and is removed from the system by the operating system. So when the process completed its job, then it should be removed from the system by the operating system. That's what the termination is. And after termination, all the resources are released, like the memory occupied should be released so that some other process can take that space. The files this process was using should be released so that other process can start using those files. Yeah, once a process is using a memory, then that memory should not be allowed by another process to occupy, because it's going to create havoc. And once a file is being used by one process, then we should ensure that other process should not use the same file unless until it is essential. Then we must ensure that once a file is opened by one process, other process should not use it. So for that we have some mechanisms which we are going to look in the coming sessions. But once the work is done, we need to release these files so that other process who are waiting for that can now start using it. So that's what happens after terminating a process. And then we update the process table that any given time which all processes are active. A big list is there which we call process table, how many processes are working, and details like name of the process, the ID of the process, when it began, when and what resources it is using, which memory it is occupying, and who created it, and all details are there with that. And that process, has it created any child process? If so, what is the ID of that child process? All the details are there in this process table. So once a process is no more existing, then this process table has to be updated. That line has to be erased from the process table, otherwise it creates havoc. Then notify the parent process, if any, that the child process you have created is terminated. Now if you don't have any other work, if you are waiting only for termination of this particular process, then you can continue your own actions. You don't have to wait anymore. So for that, we notify to the parent process about the termination of this particular process. Then how many ways a process can be terminated? A normal termination, when the process completes all its job and it exits voluntarily. So it's supposed to do something and it has done everything, then it will close and say, I have done, so let me get terminated, and it exits. So it calls exit or reaches end of the program. Like in C, we just say return 0, that says that it's exit 1. So we just know that it has come to end of that program. So it just returns back 0 to whoever has called that and gets terminated. Maybe abnormal termination, forced to terminate due to error or unexpected situation. So you are trying to use some instructions that are not supposed to. That means, say, divide by 0. You are trying to divide something by 0, then it's going to be into an infinite loop. So we want to make sure that you don't divide anything by 0. But what can we do? If you are trying to calculate A equal to B divided by C, and if for some reason C value was 0, and if C value is 0, and if you try to divide it, how do you divide? By successive subtraction. So B by C, if you want to do, we keep on subtracting C from B till the difference goes down to 0, and count how many times we subtracted. And if we try to divide B by C, and if C is equal to 0, then B minus 0 is B, B minus 0 is B, B minus 0 is B. Do any number of times B minus 0, it's going to remain B only. It will never go down to 0, and hence this process will never stop. This is what we call infinite loop, and this is what we call the system has gone, what you say, it's just a stop working. It doesn't respond to any keyboard, mouse, anything, nothing. So that's a crazy situation we get into if we try to run that. But yes, the next programming languages do have technique to just check before any division operation is done. Just check what is C. If it is 0, just don't divide at all. Don't execute that instruction. But yes, without executing that instruction, the next instructions don't have any meaning. Therefore, what is fun in continuing? You just say it is not possible. So raise an alarm, say that here you are trying to divide by 0 and it is not going to get any answer, and hence terminate the process and display an error message saying that this is a problem, and hence it was forcibly terminated here. It did not complete its work. In between something went wrong, so we have stopped it. Operating system is free to stop any process if it is going to disturb the whole ecosystem. So instead of that, better stop it. So that's what we call abnormal termination. It is forced to terminate due to error or unexpected situation. So this is due to runtime errors. This is not visible during compilation, it is only visible during running it. So all these are the runtime problems. So maybe divide by 0 or maybe inviolate memory access. You are allocated a particular block of memory and you are supposed to use memory only in that, but if you try to access memory from neighboring process or something, then definitely alarm is raised, so it will be forcibly blocked. So why it happened? Maybe for many reasons, but yes, we are not allowed to access others information. One process should access information related with that process only. It cannot access other process information. If you try to get into other, then something alarm is raised by the operating system, and because of this problem the operating system is allowed to forcibly stop the process. So that's abnormal termination. So it can be unhandled exception and all that. Then it can be killed by the operating system. So it is operating system is forcibly terminating a process, like when the uh, process is trying to use a memory, and for every process some memory is allocated, and if it's trying to use more memory than it is allocated, then the operating system should intervene and kill that process. Otherwise it starts indefinitely using the neighboring memory and may create problem to other processes. Or CPUs, when you are working with multi-processing environment, then each process is allotted some number of CPUs, then it should work within those number of CPUs. But if it tries to use more number of CPUs, then definitely it's going to create a problem, and hence alarm is raised and that particular process is killed by the operating system. So this is done to recover the deadlocks. What deadlock is? Yeah, we have this in detail to discuss when we are working with resource management, when we are working on process management, when more than one process is trying to use a resource like memory, file and all that. So we look at this in detail, what deadlock is and how to recover. So that one of the process is to kill a process that is holding some resources indefinitely, unwantedly, and creating problem to all other processes. So if one process is killed and all other processes can survive without difficulty, then it is better to kill one process, and that's what is done by the operating system. Or if you find that there is security threat in that process, so if the process is having some virus or worm, then make sure that the operating system kills it. So forcibly that particular process is ceased to exist. So this is forcibly done by the operating system, and that's what we call killed by the operating system. Or it may also be killed by the parent process itself. So parent process may explicitly terminate its child process. So here what happened is the parent process creates a child process through fork statement, and then it starts waiting for the child to complete, and some specific time is given for the child process to run, and if child could not complete its task within that period, then parent process may understand that so child process is having some sort of problem, and instead of creating problem to the whole ecosystem, the parent process itself can kill that child. So that's another option. So here the parent process may use instruction like kill or some similar. That's it for now. If you feel that this session is of any information, please do like, share, comment, and please subscribe to this channel. Thank you.